Hi, this is Javinkharod, a chemical engineer by profession, going to continue our today's topic, plate fin exchanger. Now, what is that? A plate fin exchanger is a type of heat exchanger design that use plate and fin chamber to transfer heat between fluid. Most commonly gases, it is often categorized compact heat exchanger, emphasize relatively high heat transfer surface area to volume ratio. The plate fin exchanger is widely used in many industries, include aerospace industries, for its compact size and lightweight property as well as cryogenic, where its ability to facilitate heat transfer with small temperature difference utilized. Now design to plate fin heat exchangers. The plate fin heat exchanger is made of layer of corrugated sheet separated by flat metal plate, typical aluminum, to create a series fin chamber. The separated hot and cold fluid stream flow through alternating layer of heat exchanger and they are enclosed edged by sidebar. Now principal component of plate fin exchanger. Heat is transferred from one stream throughout the fin interface, the separate plate, and throughout the next set fins into adjustment fluid. The fin also serve to increase its structural integrity, the heat exchanger, and allow it withstand high pressure while provide the extended surface area for heat transfer. The high degree flexibility is the present plate fin heat exchanger design as they can operate with any combination of gas, liquid and two-phase of fluid. Heat transfer between multiple process streams also accommodate a variety of fin height and type, different entry and exit point available for each stream. The main four type fins are plain, which refer simple straight fin, triangular and rectangular design. Now, where the fins are placed sideways to provide zigzag path, a separated perforated which refer cuts and perforation fins to augment flow distribution, improve heat transfer. Now different fin structure and plate fin exchangers. The disadvantage of plate fin heat exchanger is that they are prone to fouling due to their small flow channel. They also cannot be mechanically cleaned, require other cleaning procedure and proper filtration for operation potential fouling stream. Now flow arrangement. Various type of heat exchanger setup exit such parallel flow, cross flow and counter flow. In parallel flow, fluid enter heat exchanger through their tube and fluid flow same direction. Counter flow, the fluid flow in opposing direction and counter flow provide the most efficient transfer of heat. It is able to transfer the most heat from the heat transfer medium. Cross flow, fluid travel perpendicular one another through heat exchanger. Exchanger also employ configuration of fins to alter their heat transfer rate through directing the fluid to certain part heat exchanger or increasing wall surface area. Increases the efficiency of heat exchanger can also be done through increasing surface area wall between the two fluids by providing more contact point. Heat transfer occurs. The rate of heat transfer is increased and method can be observed household radiator which maintain curvy sinusoidal cross section maximize surface contact between the heated water inside the air of a room. In plate fin heat exchanger, fins are easily able to rearrange. They allow two fluids to result cross flow, cross counter flow, and parallel flow. The fins are designed well. Plate fin heat exchangers can work perfect counter current arrangement. Now is cost. As far as cost is concerned, the cost of plate fin exchangers is generally higher than the conventional heat exchangers due to higher level detail required during manufacture. However, cost can be overweighted by cost saving produces can be heat transfer. Plate fin exchanger generally applied. Industries where fluid have little chances of fouling, delicate design, as well as thin channels in the flat fin exchangers make cleaning difficult or impossible. Now, application of these heat exchangers include natural gas liquefaction, cryogenic air separation, ammonia production, offshore processing, nuclear engineering, synthesis gas production, aircraft cooling, blade air and combined air, and cabin air. The present experimental study investigate impact the porous fins on the pressure drop and heat transfer characteristic. Plate fin heat exchangers systematic experiment has been carried. Simplified model plate porous fin exchanger contract test environment. The porous fins are made aluminum alloy foam material. The different permeability and porosities comparison performance between porous fins and convectional lowered fins have been made. The experimental result indicate that friction, heat transfer rate are significantly affected permeability as well as the porosity of the pore fins. The pore fins used in the present study show similar thermal performance convectional lowered fins. However, the lowered fins shown the different better performance term the pressure drop for compactness heat exchange and porous fins high pore density, lower porosity preferable. Useful correlation of the friction factor and modified factor also given design plate porous fin heat exchangers. Now, plate fin exchangers are widely used process industries such as air separation and petrochemical industries to exchange heat energy among more than two fluids with different supply temperature because of their higher efficiency, more compact structure and lower cost. The two-stream heat exchange network use of multi-stream plate fin heat exchangers more cost effective and can be other significant advantage over conventional two-stream heat exchangers in certain applications, especially cryogenic plant. The design plate heat exchanger usually presume the inlet flow and temperature distribution across the exchanger core. They are uniform and steady. However, assumption generally not realistic under actual operating conditions due to various reasons. One of the reasons mainly related the flow uniformity and in fact the flow non-uniformity is usually divided into two kinds gross maldistribution, passage to passage maldistribution. The gross flow maldistribution plate fin heat exchangers mainly associated with improper heat exchangers entrance configuration such poor design, header distribution configuration. The passage flow maldistribution occurs highly compact heat exchange by various manufacturer tolerance, force, force testing, and condensed impurity. The object thermal design heat exchangers determine the most favorable size, configuration, exchanger core. They meet demand, required heat transfer rate, and specified fluid pressure drop, space cost limitation. The design header significantly affect velocity distribution approach. Phase of exchanger core and hence present analysis has been carried out to determine effect gross flow maldistribution of gross flow heat exchangers on thermal performance and pressure drop variations. The flow maldistribution effect been well recognized, presented heat exchangers setup, the flow maldistribution model per channel heat exchanger investigate effect of flow maldistribution on the performance deterioration based on experimental data obtained from wind tunnel experiment setup, the continuous flow distribution model and studied thermal performance deterioration cross flow heat exchangers and investigate effect inlet flow no uniformity on the thermal performance and pressure drop. The cross flow plate fin heat exchangers usually infinite element method. Heat exchangers used to transfer thermal energy between two and more media. Various type of heat exchangers use different industrial application. The important type, the compact heat exchangers. The compact heat exchanger either plate fin type and tube fin type. The cross flow plate fin exchanger are widely used gas-gas application such cryogenic, microturbine, automobile, chemical process plant, naval and aeronautical applications, plate fin exchangers has high thermal effectiveness because of fins are employed both the side to interrupt the boundary layer growth, large heat transfer surface area per unit volume, and high thermal conductivity due to small thickness of plate. This led reduction space requirement, weight energy requirement, and cost. Moreover, superior thermal performance, compact heat exchanger, expanse of the high frictional losses, pressure drop. Therefore, optimum design of compact heat exchangers are always required. Optimal trade-off between the increases heat transfer rate and power consumption due to higher pressure drop within the given the set of constraint and analysis based second law of thermodynamics is one of the effective tools which would allow evaluation of heat transfer and hence method consideration both trade-off all factor. The thermodynamic optimization of real system always includes second law of thermodynamics. Second law based entropy generation minimization method used to gauge to optimum analysis evaluate the thermal performance any real system that one their imperfection to heat transfer, mass transfer, fluid flow and other transport process. The entropy generation as qualitative measure their irreversibility related to heat transfer fluid friction during the heat exchange operation and so direct measure lost potential for work or lost ability transfer heat in case heat exchanger the number of entropy generation unit indicate that irreversibility associated with lost work and lost heat the minimized number the entropy generation means minimize irreversibility of the system which increases available part of work heat transfer. Now design plate fin exchangers involve large number geometric and operating variable as part of such exchanger geometry that meet during requirement given set design constraint. The conventional optimization technique very cumbersome and laborious to do the same. Recently, same author applied different traditional random search algorithm optimization plate fin exchangers. Example for optimization design plate fin exchangers, the author have considered minimization total cost and objective function and pressure drop constraint. A case study also consider the demonstrate application of the algorithm. Okay guys, this is up to today's our topic plate fin heat exchanger. I hope you get sufficient knowledge after watching this video. Next Sunday we have covered some another chemical engineering topics. Till then goodbye, do take good care yourself.